Kubernetes outside the cloud. So some jargon alert, right? We all know that this is not the only way to deploy Kubernetes, but we'll standardize for the purpose of this talk. We have a Kubernetes node that's generic. We have a Kubernetes master node, which has API server, controller manager, kube schedule, and etcd. And we'll have a Kubernetes worker node, which has the kubelet, ingress, kubeproxy, and all of the pods that will be running in your cluster. Right? That's one jargon. Kubernetes master, Kubernetes worker. Another one. This is pronounced 3 by 5 cluster. The one on the left is the number of masters. The one on the right is the number of workers. I'm going to use that jargon from here on out. Right? So cluster logical view. This is how I'm going to arrange it. Anything within that rectangle is Kubernetes. Anything outside is outside Kubernetes. All right. 1 by 1 cluster is non-HA, non-resilient, because if your master dies here, your metadata is gone because etcd is gone, right? We can't recover from that. If your worker dies, then your service is disrupted. Can't recover from that too, right? Because all of its data was in that worker, it's gone now. All right. So there's no way for us to say ha, right? It's not ha. All right, non-HA, non-resilient, right? Here is 1 by 1 cluster plus offline backup plus HA NAS. This makes it non-HA because if your master dies, you have service disruption. If your worker dies, you still have service disruption. But you can recover from that, right? You are resilient because your etcd is backed up in some target outside of the Kubernetes cluster. If you have an HA NAS, like, I don't know, Gluster FS, FRBD, whatever you want to use, right? Oh man, okay, thank you. Whatever you want to use for your HA NAS, right? You use you use storage classes to, wire the HA NAS, disk images into your pods. If that worker dies, or even if your pod dies, you can recover from that because that gets reconnected. All the Kubernetes magic happens. It's non-HA, but it is resilient, right? All right, now here we go. This is now true hop. 3 by N cluster plus offline backup plus HA NAS, right? We have a master fault tolerance of 1 here because according to the design of etcd, or as per RAF protocol, right? If you have 3 etcd members in a cluster, you can tolerate 1 dying. Better replace that very quickly because if another one dies, your cluster is gone, right? So it's the same thing here. You have a master fault tolerance of 1, and you are resilient because of all of these backups and the HA NAS, right? And another thing that's new here is because now that you have multiple masters, you will have multiple API server endpoints. So you need an HA load balancer at the top, right? And you need your kubelets to be pointing to that kube API single endpoint right there at the top, right? Because you don't want to have to manage the different endpoints of your kube API server. You just want to point your kubelets to that one single endpoint, and that'll take care of the rest, right? I put in there customer HA load balancer, customer, right? Because we expect here at Teradata, we cater to Fortune, I think it's Fortune 100, Fortune 1000 companies. For sure, they have an HA load balancer. They don't want to buy anything from us in that aspect. They just want to be able to say, okay, here's the endpoint. Here are the HA kube API servers and the kubelets, and okay, we're done. We have a cluster going on. So those are the things that you need to consider when you are deploying outside of the cloud, right? First of all, the HA load balancer, the etcd offline backup target, the HA NAS. When you're in AWS, you got all of this ready, right? You can just make an API call to ELB, to S3, to EBS, and you got everything that's outside of the Kubernetes cluster. But for bare metal, for on-premise installations, you need to take care of that. You need to consider that. And here is the 5 by N cluster, right? It's the same thing, but you now have a master fault tolerance of 2 because you now have 5 etcd nodes right there in your masters. And so let's talk about very quickly now, the cluster physical view. So far, this is the logical view. How would you deploy that in bare metal, right? How does it look physically? Here's one example. 1 by 1 cluster, non-HA, non-resilient, in a single 2U chassis probably, right? Or 1U, whatever you want. You have a hypervisor there, maybe KVM, right? And you have your Kubernetes master running in a VM, and your Kubernetes worker running in a VM. There are 3 major reasons why we would use a VM in this case, but the VM is not a hard requirement, right? Here is one hard requirement. Number 1, avoid process resource starvation. etcd is very sensitive to disk and network starvation. right? You don't want that to compete with your HA NAS if the HA NAS resides in that same box, right? You want to be able to isolate those two. And the same thing with your Kubernetes worker, which is going to be running the pods. You don't want that to compete with your etcd resources, right? So that's one requirement. Another requirement is protection from malicious containers, right? As of right now, even though the last podcast that I heard where the project manager of Kubernetes, or was that Google Cloud, but anyway, one of those really smart guys, they said the best security boundary, the best known security boundary right now is the VM. And there's a number of projects that are working on further refining that boundary to all the way to the pod, right? Right now we have some security boundaries in the pod, but it's not foolproof yet. As of today, the foolproof way is VMs. So that's one reason why I put in there a VM. But again, if there is another way to satisfy the second requirement without using VMs, that's all good. That's perfect. Here's a third requirement though for why I would suggest a VM. Here is a PREF profile, a product radio something profile. I don't know why I'm forgetting that because I drafted this profile. That's how I created that framework. But basically, what I just want to show you is the one that's pointing southeast, build complexity, and northwest, marketability. Right? The more build complexity there is in your product, the less marketability is your product. Right now, operating. But they affect each other. Because the more complex your build is, the more you focus on your internal problems instead of your customers' problems. So that's one reason why we are proposing VMs for our products, right? For your products, it might not be the case, right? But in our case, we want to get a nice PREF profile here. If you want to know more about that PREF profile, just go to bit.ly/p.ref.
So the PREF thing is, these are opposites. One goes this way.
Go to that URL and you'll see a video of me talking about that thing.
Oh, wow.
All right, so here is, again, non-HA, non-resilient, one-by-one cluster, right? How do we make it HA? How do we make it resilient? We just add an offline backup target and HA NAS, right? Same thing as before. How do we make it fault tolerant to 1? Just add 2 more, right? There might be some downtime when you increase the number of nodes, but it's as simple as that. Just add more. How do you achieve fault tolerance of 2? Hey, add 2 more, right? And that's basically it. That's how you do with Kubernetes. What do you think? Just go to my website, relaxdiego.com. That's also where I talk about the PREF framework, which the meaning of I have forgotten, probably because of the awesome Vietnamese beer that we have right there. Thank you very much for that beer, by the way. So yeah, I talk about DevOps, software engineering, agile, product management, the whole gamut of things in that website. Thank you very much.